Thank you for the invite. So I am Viktor Qvarfordt. I lead engineering at Sana, where I've been for more than 6 years. So I'm one of the early employees over there. And I'm here to talk to all of you about how AI is reshaping software development. So the engineering team at Sana is about 50 engineers. We're building 2 products, a learning platform and an agent platform, Sana Agents. So I will speak kind of from that context about how we are operationalizing being more AI enabled in how we build products. But I'll try to talk about all of this kind of from a general perspective as well. What I believe to be the do's and don'ts of being a software engineer today and going into the future. And for the Q&A section, I'm really curious to sort of hear your takes and discuss this from various perspectives. So what I want to cover in this, I believe it's 20 minutes and then some Q&A, is reason around this a bit on the abstract level, then go into a lot of details, because I believe we are all software engineers in one shape or another, and then try to wrap it up. And on the very abstract level, I think we have to start shifting our minds a lot as software engineers if we haven't done so already. I like to say that software engineers should think about themselves as agent operators and system designers, much more than like programmers. If the fraction of lines of code that you check into Git is like, if the majority is written by you and not an LLM, you should maybe start questioning what you're doing. And what I mean by that is, of course, like you guide it and so on. You are the agent operator, but make it, like, design your workflows in such a way that the machine can do the menial work, writing the syntax, and then increasingly do more and more and more. And I'll go into how and what you can do to enable the tooling to do more for you. But I want to say early on that, like, yes, I'm very aware, and we should all be very aware of where do the LLM and codegen tools perform well and where don't they. So I see a huge difference of how people speak about these tools when I talk to my friends that are like normal front-end engineers or like general full stack versus my friends in kind of academia, where they write code for simulations and maybe trying to use code to prove some theorems, these kinds of things. So in the first context, everything is like nice and happy, and the LLM can generate very relevant code. But if you're doing something fundamentally new, i.e. research, the LLMs are surprisingly bad in many cases. And I think this is an important intuition to have. Sometimes it's easy to think that the LLMs are better at generalizing than what they actually are. So like a lot of normal software engineering is in distribution of the training data for the LLMs. While if you're doing something fundamentally new, the LLM has kind of never seen that, and it will be rather bad, or relatively speaking at least. So that's also something to guide a very important rule of thumb when thinking about how to use the LLMs. If you struggle to get good results and you're like trying to prompt it more and more and more and more, it's going to be maybe not the best approach. Try to figure out what's natural for the LLM. Stay in distribution. Stay close to what it has seen, because they are, so to say, not as good at generalizing as you might think. It's just that the training data is massive, right? All the text produced by humans. So it looks like it can generalize, but maybe it's not so much. And then again, or like, yeah, what else? The space is moving very fast. So like, allow yourself to shift your tooling much more rapidly, is I think a super important observation. And then this is an important point of like the codegen tools are good in small projects. I think that's clear from all these kind of no-code codegen tools out there that are really popular. But also in the context of Cursor, they struggle a lot in small code bases. So they actually have kind of a post on what you can do in a larger code base. So this is one thing to look into. And obviously, like writing these cursor rules is super powerful. And I'll talk more about that. Maybe before, like I want to gauge sort of where we are all at in the room. How many regularly use cursor or an equivalent? Very good. How many use an equivalent to cursor more often than cursor? Okay, okay, cool. Is that like windsurf or Klein or Z? Okay, windsurf. Augment. Okay, continue. Very fun. Yeah, so they talk a lot about like how you can structure the code and these kinds of things. We'll get into that. But essentially, if it's easy for a human to navigate, then it will be easy for an LLM. So like it's not like we're starting to optimize for something that doesn't make sense for us humans. But all these optimizations should really make sense for us as well, because we will be there guiding the tooling, right? Some kind of code patterns that I think are quite interesting is to make the code base have clear interfaces. Well, obviously, but maybe this one. Each feature should be self-contained in a folder. Maybe not truism in general, but this distinction of how files are structured in a Unix file system /var/etc, etc, versus kind of this .pkg folder in how you install on a Mac. It's a very vague analogy, but everything is in one place. And having collocation of code and documentation and everything becomes quite important. It's much easier to specify relevant context when you're working on a subset of your very large code base. That's why I write here to have it be more modular and maybe even hierarchical. So every feature maybe has its own sort of, everything relevant to a feature is in one folder. Imagine if you're writing front end, maybe you put your hooks and components in different different folders at the root. Pull them all in close to the actual feature. And then you can have sort of a hierarchy of these meta features. Maybe some parts of the product and another part of the product get bundled. But I still believe in monorepos, but create nice interfaces. And the value of humans becomes more and more to be like, we have the taste and the opinion. We set the direction and the architecture. So do express your values and opinions and design patterns in cursor rules, and try to have that maybe even be the source of truth for onboarding as you introduce new engineers. At Sana, we usually have like someone new joins and they're like, okay, where should I start? How do I get on into the code base? I tell them to just ask cursor in the code base. It will, of course, just read the relevant readmes and so on. And that's actually a very good way to figure out whether or not you have a structure that is understandable to the LLM. I mean, you just ask it, like, what does this code base do? If it doesn't give a very like sharp answer, then you maybe need to fix your docs or structure. Some other interesting code patterns that are in part counterintuitive is to have the code be much more flat. I'll show an example on this. So not over abstract, and we have somewhat been trained to create abstractions and pull everything out into small functions, and so you can take that too far. And yeah, I want to show a simple example in a bit here. Another high level kind of important thing that I think is a very cascade effect of us using CodeGen tools is to enable everyone to work outside their area of expertise. Essentially have everyone become full stack engineers to some extent at least. So front-end experts should be able to write UI updates. I think this is a thing that distinguishes really productive teams from less productive teams today, and especially going into the future. If you're in this situation where like you're a backend engineer and you kind of cannot touch the front end, you need to sync with some other team, sync with their roadmap, all of this, you're just like, you get stuck, everything was really slow. Yeah, most engineers are full stack. But I appreciate that you challenging me on this, because there's a nuance, of course. For example, our back-end infrastructure engineers. They are like so far detached from the front end that they rarely have a reason to touch it, perhaps. And the people on the very other side of the spectrum, working more closely with design, like the pixel perfect touch and feel UI implementation, they won't be touching the schema migrations.
I was asking because I see the value of it. See how that plays out. So I got for modern cars. So means.
Yes, and a reason for this is actually I can share. So we have two products, right? The first one is Kotlin on the back end and TypeScript React on the front end. When we introduced our second product, Sana Agents, we decided to write that fully in TypeScript. So TypeScript full stack, we're using tRPC as the full stack or the front and back end communication layer. So you easily share types and everything. That was very intentional of this, like, especially at the startup or when you need to iterate quickly. You want to enable everyone to work end to end. Imagine one person being able to set the database schema and use those types and everything all the way out to the front end. When you can hold the code, so to say, in your hands, you can be so much more productive than if you have this like syncs and roadmaps and blah, 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 blah. But there's nuances to this, to what extent you can make it work. And today, what's really cool is if Cursor is, I think, if I'm simplifying, like best at just like front-end implementation. It's localized and it doesn't have state like a database. So people that work more on the back end and now we added this type, it needs to be visible in the form. These things are now, like Cursor just does it for them. I think that's a huge enabler. So this can be fun to talk a bit about. I personally think Cursor is on average like best right now, but there are so many alternatives and everything is shifting. So it's very fun to hear people using quite a wide range of tooling here. And MCPs, all the rage now somehow. So I think I want to spend just a minute on that. And I saw just recently OpenAI added MCP support to the response API also. So you can just hook up an MCP server and it becomes available for the in the API then. But MCP on some level is just a badly implemented API. Badly implemented in the sense that it's usually just standard input-output, most of the MCP servers. It's great if it's like you're running it single user on one computer, sure, but you can't really use them in a production setting. But there are these SSE alternatives and so. But it's a great concept because it just standardizes how we can expose tools to, in this case, Cursor, and it doesn't matter that they are not scalable, the implementations. So I want to highlight some interesting examples. So this is what we have, checked in, but people are playing with a bunch of different things. This one, browser tools, is quite fun if you're working with kind of front-end development. So this allows your Cursor agent to have access to your running browser. So you can ask it to it knows it knows what elements you have focused in the debugger. It sees the network errors. It sees the console outputs. So a powerful iteration loop is, of course, when you have it just see lint errors and stuff, and it just runs. With this, it can also see actual runtime errors in the browser. Other nice MCP servers that you can hook up to Cursor. I think like if you're working with GCP and managing a lot of resources, the GCP MCP is pretty nice, etc. Right, I want to say, I think we're all in this room, of course, having this enabled. So I think we should all be leaning into having these tools do as much as possible for us, run automatically, and rely a lot on static tests like lint rules and good types and so on, because it does pick up on all of this in the IDE. Maybe you click some of these boxes depending on your level of paranoia. But fun thing, I don't know if everyone knows, but Cursor is currently background agents. So why I'm like, okay, you can already have it run agent style in the IDE, but Cursor is currently preview releasing, and soon it will go into general availability. Background agents, so they will spin up an IDE in the cloud, and you can just spin it up. And when I talk to the folks over there, a lot of them are actually internally running with the O3 model, which is a thinking model and very slow, right? But they give it rather heavy tasks. And then you don't want to sit there and wait for it or have like 5 cursor windows open at the same time. So they are now going in the direction of kind of what Devin was doing originally. But I think Cursor is very strategical in how they're navigating the space, first being where we are as engineers, and then increasingly just automating it, having it run in the background. So this, I think, will be a really interesting shift. Are we ready for it? Is the tooling ready for it? Are the LLMs competent enough? Maybe soon-ish. So the timing here is quite interesting. And I think the fact that they are introducing it now is an indication that they believe the LLMs are starting to get stable enough for that kind of use case. One quick mention on like cursor rules, very powerful. And especially if in a large code base, you can sort of set the scopes and so on and guide it. But I think still automatic checks like types and lints are to be preferred somehow. They are strict, you have guarantees. They show up for humans. The more you can rely on this, the better. But some patterns, of course, need to be expressed more vaguely in natural text. So let's jump to some code examples or patterns. I hinted to this, like flat code is good. I want to show explicitly what I mean. Let's maybe look at the example first. This is a bit of like contrived example, of course, but I said this thing, we've been kind of taught to pull out everything into small functions, like get username, first name, space, last name. But if you do this a lot and like put them in different files and you think I'm doing the right thing, it gets very messy, complex, difficult to navigate for both humans and LLMs. So just like inline stuff, if it's rather simple, this is so much easier to read, even for humans. And I think this becomes more important now as we have LLMs generate and read code for us, because they lack context so much. So if these are in other files and you just see this, like what's actually happening is not clear. And then they need to do like lookups in those files. Everything becomes really slow somehow. And it maybe ties back into this idea of lean into the natural tendencies of the LLMs for good and bad, I don't know. But I think we all have made the observation that they prefer to write very flat code. Like if you're reusing the same component a couple of times, it happily re-implements it, so to say, or writes out the class names or whatever. Is that good? Is it not good? There's a balance to this, of course. So a bit less composition, I see in our code base and others, is to be a somewhat common pattern. Make the code like be easy to read linearly from top to bottom and without jumping through many files. And maybe another reason for why sort of abstractions become a bit less important is perhaps that code will be reused, I think, less in the future and just rewritten all the time, because it's cheap, it's fast. That seems to be the natural tendency of the LLMs. As we, as engineers, transition from being the programmers to the agent orchestrators, so much more code will be written. And I think the demand for code as a consequence of that will increase. So our jobs as programmers will for sure be replaced. But someone needs to coach or operate the future programmers, i.e. the LLMs. And the demand for this role is going to be very high. Everyone will want 100 times as many lines of code produced. So we'll have different kinds of headaches as engineers. The other example, final slide. The front-end team is now in the transition of switching. We were using styled components to Tailwind. I'll make the comparison very simple here. Everything becomes more concise, but most importantly, things become inlined. Again, flat, collocate. So the card component up here is used down here. It's nice in some way. You have a semantic name for it and so on. But here, the usage and the declaration of it is like inlined. Everything is collocated. This seems to be much easier for LLMs to deal with. Yes?
Sure.
How do you ensure that the styles are synchronized across? Yes, very good question. Two approaches to that. You can actually we have lint rules on what classes are allowed and not. So that's cool. You have static guarantees. You want to maybe disallow a bunch of weird colors and stuff, and you maybe want to kind of enforce usage of your own custom classes. That's one example. The other is to express your design philosophy in cursor rules. So a mix of static. Yeah, exactly. And of course, maybe the card in a real world scenario, maybe the card component would actually be a component that exists that is reused. So with that, I want to conclude and sum up the sort of observations and what I believe to be the do's and don'ts in this context. Collocate files, modularize, create a nice hierarchical structure in your monorepo. Write increasingly flat code with maybe less composition, in the sense of like less jumping to this file, and somewhere you have some root component. Codify your architectural decisions or system design preferences. So we humans will increasingly be the ones contributing with a taste. What does good look like? And then have the LLMs run with it. Enable everyone to work outside of their area of expertise. Everyone becomes a full stack to some extent, or like we want to move in that direction. And give all your devs very easy access to good tooling. I was surprised, but when we enabled like cursor, the business plan, so that everyone just signs in and they don't have to expense it themselves. If a bit more engineers start using it, to like help everyone just lower the bars to adopt all this new tech and be really quick, explore, try different stuff. I think that's where a lot of your edge as an engineer will be, in having the competence of how to navigate and orchestrate all the tooling that exists. Thank you. And now we have time for questions.
Sure, great talk, and I'm definitely all aboard with what you're saying about the agent operators. I just want to push maybe a little bit, like what is the next step? Suggestion, another word that's thrown around a lot is everybody becomes a manager. So maybe agent manager is the next step. So I had this sort of revelation this morning when I tried out the new release from Google AI yesterday. What's it called? Judas, which is more like Devin or Codex.
Yes.
And probably also like a background agent. So I'd be curious to hear what you have to say about it. But I just fired up a task this morning to my code base to give me a solid readme for a relatively complicated repo, and it came back a few minutes later with a solved task. And I get 5 tasks a day. And to me, it's like I have like a junior developer half time with me for that time, or maybe. So I become more of a manager to that agent. I just have to structure the tasks very well.
Yes.
And have it do it on their own, which is totally different from the cursor paradigm where you're always present. Any insight, any revelations from the background agent mode or something you want to share about that?
I think this is a great point you're raising there. Of we see many of the big labs and so on now releasing this more autonomous coding agents, and Cursor, like they're all doing it at the same time. That's an indication that this is starting to work. Devin, I think it was more than a year ago or so when they launched it. Everyone got so excited, and then once people started getting their hands on it, it's like, oh, aha, okay, maybe not so fun after all. Increasingly, of course, they will be very autonomous and do a lot for us. And again, it depends on where you are. Are you doing something fundamentally new out of distribution? Maybe you need to be closer, holding their hand. If it's just iterating on UI bugs or data plumbing between the front end and the back end, the autonomous approach will probably be very powerful very soon. And I think you're saying something important with your job. Our job becomes to be explicit and correct in defining the problem. It's like if I studied math or like if you studied anything analytical, you probably have this intuition with you that half or more of solving the problem is formulating the problem well. It's kind of similar here.
Yeah. But people are saying something.
Thank you. Very nice talk. I totally agree on the direction where we're going. However, I'm thinking about specifically this flat code you're talking about. That's kind of reduces the reusability. And you said also that more and more code is that we can instead of reuse. I'm thinking about from the perspective of the viewer of the code. How do you deal with that? Because there's more and more code which is written.
Yes.
You deal with that with the code reuse.
Great question. So I want to say 2 things on that. One thing is, depending on how ambitious you are as you look into the future, I think one perspective is that there will not really be SaaS software as today. There will be databases and APIs, and there will be generated UIs, custom made for every individual or every department and every team. I think an example is every sales team I ever sort of interacted with, they all hate their CRM system, but the basic data is very basic. So I mean, let them just have their generated UI on top of a fundamental database. I think we'll see that much more. And that UI basically, I mean, in the very long run, maybe it's generated on the fly almost. Intermediate step is it's someone somewhat technical generates it once for the specific use case, and then the team uses it. And how? Okay, the other part is what to do with reviews. One thing is to say have an LLM do the reviewing, and
deal with it now, like to you, user.
Yeah. So at Sana we sell to large enterprises, so we have SOC and ISO certifications that we need to adhere to, which basically mandates us to do very strict reviews on everything. We're also a company that want to move really fast, and like I'm of the opinion, why should another human look at the code? If a senior competent engineer feels like this is an obvious fix, no one needs to spend the time looking at it. So we remain compliant with everything by having the person that checks in the code specify a sort of risk level on the change, and if it's low risk, we have an LLM reviewer. Yes. Sorry. Yes.
Hi. You briefly mentioned monorepo in the beginning. But I was wondering if you made like other architectural decisions to support LLMs, like going for microservices that have a smaller context so the LLM can understand it, or an easily replaceable microservice, like if you want to, are you making those kind of decisions LLM coding?
I think, one such decision was to use TypeScript full stack and tRPC, so we have the types propagate all the way. I'm personally not a huge fan of microservices, because I'm mostly operating in a context where we want to have engineers be able to make end-to-end changes rather quickly. If an end-to-end change involves deploying 1, 2, 3 microservices, you are introducing barriers for yourself. Another way to look at microservices is that, like, not always, but sometimes, in many cases, people want to have them so that they have nice separation of concerns. It's just code. If you want to have separation of concerns, go ahead and do it in one service. I think that should be the first step. And if you feel like, oh, but I can't be disciplined enough, I need a separate service. I mean, sometimes I hear this argument. But it will be messy. We need to separate it into a separate service. Then I think the problem is somewhere else. But creating the modularization, just do it in the code base. You can pretend it's a different service. You can pretend it's started from somewhere else. And then you have like 90% of the gains without the pain of separate deployments. I'm simplifying a lot, so we can chat more about this.
Okay, thank you for this talk. You talk about using LLMs a lot, and that kind of raises the question of LLMs are not stakeholders. So should we be concerned about the origin of these LLMs or about the complexity that we assign them?
Yes.
What are your thoughts about that?
So one thing is, codify what matters in documentation and cursor rules and so, but you can't always trust that they will adhere to this.
I guess in a sense you answer this because you have a review process where you have two different coders that need to understand the code and review it before it goes in. So that kind of tells me that you are aware that it needs to be reviewed by a human.
Oh, yeah.
But what about the origin? Would you be okay by using a Chinese model, for example, like DeepSeek?
I would be less okay with it. If it's just supposed to write CSS, I think Chinese CSS is very similar to my American CSS. But more generally, I think the true answer to this question is precisely as to what extent will we trust LLMs? It's exactly the same as to what extent will we trust humans. If my first interaction with someone, I will be kind of skeptical, like, oh, they give me some artifact. What is this? Can I trust it? But if we've done that dance back and forth, I say something, you say something, and like everything you say makes sense, after some time, I don't even have to check it. I will just trust you. I think it's the same with the LLMs. And then, if you trust too much, you will get burnt. But that fundamental aspect is there, right? You trust your very senior backend engineer to go into the production database. LLMs are not. I don't think you trust them because they are humans. I think you trust them because of the consistency in the interaction. It's like a game theoretic thing going on. You're playing a game with this human, and the incentives are aligned and so on. I just want to say this is very interesting. There's infinitely many nuances to this. So as you know, when you stand here and say things, you have to simplify, and I'm aware I'm doing it. So let's talk more.
Yeah, nice presentation. I have a question regarding, you talked about generating new code, right? But we have existing code which works in production, and we as developer are always quite, thinking about we shouldn't change it and all that. How do you approach that? And how do you verify the code you are generating on a big level? And obviously it will grow with time.
Yeah.
So what's the verification process of it, that it works? Are you doing some testing or what?
Yeah. Super good question. And I want to make first a kind of distinction between two classes of development. One is when you have a really robust system in production, lots of users, it's creating a lot of business value, everything. Like, it's kind of static. You want to maintain it and maybe do small incremental changes. The other context is like small startup, moving really fast, changing everything every day. I have in this conversation been talking a bit more from this perspective. So it's good that you raised this point of like, how do you work well when like the stakes are super high and everything needs to be really, really, really like tight and robust. And this is in a context, you will have a lot more tests in place. And I think a fun thing here, I wrote it but didn't really voice it over, but test-driven development with agents is really powerful. You have your tests in place, and maybe you want to make a change, so you change the tests, and then you can step back and start the cursor agent or whatever LLM agent you have. Give it access to running the tests, give it access to changing the code base, make it loop until the tests pass. I think that's a pretty cool way to work with it. But of course, if the context is really high stakes, you need to sit there and verify the results.
Or you ask them to write tests for you.
Well, yes. Either you write the test or they write the test, or maybe you have them. Coming back to this, it's all about the problem formulation. You define very clearly what's the scope, what's the problem or the solution, then have it write the tests, check that the tests make sense, then have it write the implementation.
Thank you.
Thanks.
No, it works. Yeah, thank you, Viktor. And we need to take a short break.
This is fun. Yes.
A few minutes.